Now let us start with the second part of this unit number 2. So here in this video we will discuss about the printing parameters. The first parameter is the extruder temperature. Now I have already told you the extruder, it is used to pull the filament inside the 3D printer, and here we have to set a there are two ends are there, one is cold end and a hot end, and we have to set here the extruder temperature, the temperature of the printer's hot end which melts the filament. Now for this, the temperature for this parameter depends upon the type of the filament we are using for the for our 3D printing. Now, if you see this here in printer, so here we have to see select the material. So this is flash force PLA. So for extruder temperature, here we are selecting 210. We can select here number of the material. So that is given here. For ABS, we have to select the temperature from 225 degrees Celsius to 250 degrees Celsius, and for PLA it is 210 degrees Celsius. So that is our first temperature. That is called the extruder temperature. The second temperature is the bed temperature or the platform temperature, the temperature of the build plate. Okay. Now for the PLA, it is set around 50 to 60 degrees Celsius. So this is for the PLA, and 80 to 100 degrees Celsius for the ABS. Okay. Now for what purpose this the bed temperature is set? So this is the temperature. Let us see. So the platform temperature here, this is the temperature for the platform. Now for what purpose this temperature is set? So this temperature is set to easily remove the printed part after the printing. Okay. So for that purpose, the heater is there below this plate, and the temperature is set for this. So here in case of the 3D printing, we have to set two temperature. One is the extruder temperature, and another is the bed temperature. Okay, these temperatures are also mentioned on the spool, that is the filament that we are taking. So on this spool, it is these two temperatures are mentioned. Okay. Then after that we have the layer height. Now what is this layer height? So it determines the detail and the smoothness of the printed surface. Typical range is 0.1 to 0.3 mm for most of the consumer printers. Now if you take the layer height is 0.1 mm, so the minimum layer height means it takes a longer time. So this is 0.1 mm layer height. So for this part to be printed, so it takes the 3 hours 45 minutes. And if you change the layer height 0.2, so the time will reduce to 1 hour 50 minutes. But in case of this minimum layer height, you will get better surface finish, and that we are mentioning here. So the that layer height, so it goes here. So this is the layer height 0.18 mm. So this is the layer height, it is mentioned here. Okay. So that we can change this parameter, but the minimum layer height, so it means it will take more time to print, but you will get better surface finish. The layer height, so we have here the first layer height. So first layer height means what? The first layer height is a crucial setting in the 3D printing that directly affect the adhesion of the printed material to the bed. If the first layer is not adhered properly, the entire print can fail. Okay. So the first layer height, it is very important. That means the first layer height must get adhered to the bed. Okay. Adhered means it gets stick to this printing bed. Okay. Otherwise, if it is not stick to the bed, the layers which are there on this will get removed. Okay. So like this. So this is the best one. This is too high. Okay. So we have to select the proper bed, the proper first layer height. Okay. So here this is the first layer height. So 0.27 mm is the first. See, it is greater than the layer height, so that it should be thicker, so that it gets stick to the printing bed. Okay, so that is our first layer height. Then we have the print speed. Now print speed, the speed at which the printer nozzle moves while extruding the filament. It is the speed at which the printer's nozzle is moving. Okay. Now here also, if you take the print speed of 10 mm per second, so time required is 1 hour 38 minutes. And if you increase the speed, so the printer speed, so the time get reduced. But here also the faster speed reduce the print time but decrease the print quality and increase the risk of printing errors. Slower speeds enhance detail and addition prolong print duration, but prolonged duration. That means lower printing speed. It takes more time, but the surface finish is very good. The print quality is very good. If you increase the print speed, so time will be less, but the print quality it will decline or the print quality will not as per the requirement. So where will you get the print speed? So this is the print speed. So it is a 16 mm per second. It is given here. Okay, in our 3D printer software. So 60 mm per second it is given. Okay, so that is a by the default printing speed, and the range for the speed is 40 mm to 100 mm per second. Then comes the shells. Now what is the shell? The shell of a 3D print refers to the outer layer of the object that are printed before the infill. So what are the outer layer? So these are the outer layers are there. So this is the outer layer for this 3D model, and the thickness for this outer layer it is defined, so that is the wall thickness, and the thickness is by default it is 0.8 mm, and it is increased to 0.8 to 2.4 mm. Now what is the significance of this? Thicker wall enhance the strength and durability of the print. The wall thickness is generally a multiple of the nozzle diameter. Now our nozzle is having the diameter of 0.4 mm, so it comes in multiple of that one. So 0.4, 0.8, 1.2, something like this. Okay, it goes to 2.4. Okay, now where we are defining this the wall thickness. So here we will go to this shell, and this shell thickness is defined. So this is here 0.8 mm is given here. Okay, so our nozzle diameter is the 0.4 mm. So this is 0.4 mm nozzle diameter, and the shell thickness it is double than that one. So it comes in multiple of the nozzle diameter. So 0.4, 0.8, 1.2, 2.4, something like this. Okay, so that is for the shell thickness. Shell thickness means what? It refers to the outer layer of the object that are printed before the infill. Now this is called as infill. Okay, this inner surface, this is called as this the format, or the here the inner area. So this is called as infill, and this outer area is called as the shell thickness. So here see, this is the shell thickness is 2.4 mm. So this is thicker, and this is 0.8 mm. So this is the 0.8 mm. Okay, so this is called the shell thickness. Now shells. Now what is the shells? The shells of a 3D print refers to the outer layer of the object that are printed before the infill. Shell settings are crucial for determining the stain durability and surface quality of this. So we have already seen this one in the shell. Now wall line count. What is this wall line count? So the number of perimeter lines printed for the walls. Okay. So here this is the number of shells. Number of shells means here it is 1. So only one wall is counted. 2. So these are the two wall lines are printed. 3, 4, 5 up to 30. Okay. Impact is more wall thickness increases the print strength. So if you give the wall line count of 10, so it is very thicker. Okay, so this much thicker. So for 25, this is 25 from here to here. These are the 25 wall line count. The wall line, it ranges 2 to 4 lines for standard prints, more for parts needing the higher strength. Now where we are specifying these wall counts. So let us see in the shells. Shell count it is 2. Shell counts, these are 2 means this is 0.8 and 0.8. So double two times the shell thickness is given. That is the 2 lines are printed. Okay, so this is shell count is given, it is 2. Okay, then we have the infill density. So this is the very important parameter in the 3D printing. Now the percentage of the interior volume of the print that is filled with material, so that is called as the infill density. Now it is range from the 0% to 100%. 0% means nothing is there inside the model. So this is the outer shell is there. This is shell count we have given, but inside this nothing is there. So this is called 0%. If you increase that percentage, so material we are inserting certain material here inside this one, and the 100% means what? It is totally filled with the material. So 0% means it is nothing is there, only outer shell is there, and here it is totally filled with the material. Okay, so 10 to but so by default it is 15% is given. as a infill density. So let me show you where we have to specify this infill density. So here this is infill. The fill density, it is, by default it is given 15%. You can change this to 100%. Okay, so or 0% also. 0% means nothing is there inside the 3D model, and when you specify this as 100%, so it is totally filled with the material. Okay, now the infill density, it comes with the different patterns. So the different types of the patterns are available. So let me show you which type of the patterns are available here for infill. So in the infill, this is fill pattern. So when you give the hexagon, the hexagon grid is there: line, grid, hexagon, triangle, 3D fill. So this type of the patterns will be created. So like these are the patterns. This is called as the infill patterns with the particular density. Okay, if you mention the density as 30% for hexagon, so you'll get hexagon inside. For line, then triangles. So this is called as what the infill patterns. Okay, you can, by default the infill pattern is hexagon. After that, we have the support structure. Now, this helps to prevent the overhangs and dropping in the complex model. I have already told you, if the overhang of less than 45 degree, we don't require the support. But it is, if it is greater than 45 degree, so we require the support. So likewise, we can give the support. Let me show you how the support is given. So for that purpose, what you have to do? So we have to rotate it like this, something like this. Now, if we rotate this, the our model like this, and then we will try to give the supports. Okay. So supports comes in two types. One is called the linear, another one is called the tree-like. So we will give here also the supports are available. So this is tree-like and this is one is the linear. So let us go this auto supports. And if you see here, so now these are the supports are provided. This is tree-like support. And if you select the linear support, so linear support means, see, this is vertical. This is vertical only, linear. See the difference between this linear support. One is, this is linear, and this is tree-like supports. Okay, this is tree-like support. Okay, so support is given something like this. Okay, now you have to be very careful while giving the supports. Now and again, you have to take care of the orientation. So I will not keep this model something like this. So what I will do? So I will rotate this and keep it 0 degrees Celsius. So like this, and now in this case, it will not require any support. Okay. So the part orientation, it is very important. So that I have already explained in the previous video. So if the overhang is greater than 45 degree for your model, so support is needed. Okay, you have to give the support. Otherwise, if the support is not there, so your filament will drop down. If the support is not there, okay, and this part, so the 3D printer will not build this part. Okay, because nothing is there at the bottom, so your filament will drop down. Uh, uh, so it comes directly to the ground. Okay. Now bed adhesion. Now what is bed adhesion? So bed adhesion comes in the three forms. That is, before building the 3D printed part, at the bottom we require certain base. So that comes in the form of the bed adhesion. So it comes in terms of the skirt. So skirt is here, then beam. So beam is here, and raft is also here. So this is the raft is also there. So let me show you what types of the raft. So raft is here, enable raft. So let us see. When I am giving the raft, so raft will create it at the bottom. So this, you see this one. So this is the raft here. So that is created here. Okay. So this is the raft. Okay. Let me close this. I will delete this. I will again take the cylinder here. Now let us give the raft and slice. Okay. And now you see this is the raft. Okay. So at before starting the printing, actually we'll get the base at the bottom. So that is, this is called the raft. Okay. Now let me show you the another one. We have beam also. Let us see if we get the beam. So see, this is the beam. Okay, this is the beam pattern. So beam pattern is something like this one, circular. Okay, let us check the difference between this. So this is beam. Okay, so disable the beam. I'm gonna remove. So this is the choice. This is your choice whether you want to give uh, the raft or beam. So if I say no, so there will not be any base at the bottom. So this base get removed. Okay, uh, this is the single line is there. Okay, but the raft is not there. So what is that the so this is these are the base, that is the base is there, and on which on this base the 3D model is formed. So there are three types: one is skirt, beam, and the raft. After that, we have the cooling. So here we have the cooling fan. In the by default, the cooling fan is operated. Helps to solidify the extruded filament quickly, improving the overhangs and the bridging. Okay, proper cooling is very important. If the cooling is not proper, see you see the defects are there here. If the fan is off and if the fan is on, so see the print quality. Okay, so that comes in the form of the cooling. Okay, so these are the printing parameters.